expecting you to know how to do it.
So
They're
what?
expecting you
To go and
no,
copy?
no, not to go and copy. They're expecting you to struggle and stretch, ask people and see how you could come to a conclusion on how you could do it. They don't expect you, of course, nobody expects you to sit down and write all those codes. I mean, even a professional will know how to do that. Even those who know how to do it today, it took them time for them to study, ask questions, hard meets until they were able to do it. So don't feel like that when you cannot do it. You will know how to do it when the time comes.
I've looked at people's codes. I'm trying to figure out what we are dragging it at, but I'm still not getting the picture.
Don't worry, that's why we're having all these meets so that we could get to understand some of the concepts. Okay?
The person you're bringing, is it somebody that have gone past us or a new person?
Yeah, like it's somebody from I think cohort 8. Yeah, okay. Cohort 8. Okay. Yeah, cohort 8 or cohort 9. Okay. So that being said, yeah.
Thank you so much, Mr. David.
Okay, sir. Thank you too. Okay. Into the meet. I mean, it's always great when we gather like this to share our knowledge, and I believe we've had all these our sessions before now, and we know how. It's your mind. You only speak when you are authorized to speak, and when you want to speak, you raise up your hand. There's a hand icon in the middle of the icons at the bottom of your screen. Just click on it, and then you'll be given a chance to speak. And someone from older cohort, maybe cohort 9, I think, so cohort 9 or 8. So please, while he's speaking, you may want to just relax. Okay, don't rush to asking or don't talk when he has not asked you to talk. Please, just mute your mic and rest when he gives the chance for you to speak. Or just raise your hand and stay back. When he says speak, then you can speak. Okay, so I will not take much time so that we'll be able to finish up early enough so that those of us from is it Central Africa or East African? Because I know it's late today, so we could go and rest. So I'm so happy. I'm smiling already because our guest is already in our midst. It's always a pleasure because he was the one who took us for our Print F. You know how difficult Print F was, but he took his time and he explained the concept from beginning, and some of us were able to do the task at the end. And some of us were not able to do it completely, but at least we saw how the concept was and then we attempted it. Okay, so that is how amazing he is. And also he was the one who was supposed to be here with us last time, but something happened and I told us already he was not able to join us. Okay, so I extended our greetings to him too, and then he extended his. So we have him again in our midst today, and I'm very happy to present to you Mr. Elisha Benjamin. Please, I hand over the mic to
you. David, thank you so much. Thank you for the introduction. Before I go further, I'd like to apologize to the community for waiting for me last time. I couldn't make it. So when the opportunity presented itself, I have to set aside so many things that I'm doing to make sure that I'm here, because I enjoy being with you guys and also sharing knowledge, learning from you also, as I also learn. So it's really nice to have me here, and also exciting. I'm excited about what we're going to learn today and the entire project. So today is not going to be like last time that I took much of your time because I was trying to write the code and also explain to you. So we'll break it down this way, and I wanted to reach out to David also and make requests that we break it into 2 sessions so that we won't be taking long periods. So today I would really like us to break down the problem just like the way we did with the printf statement and the printf project. So today we'll just break it down, see how we can structure the project. Because even when I started ALX, that's the problem I'm having, the challenge I'm having. How to break a big project into smaller parts, then fuse them back together. So, and once you start, if you didn't break it well properly, fusing them together, you won't be able to tackle some tasks. You will find yourself writing some codes that are long, that you don't supposed to write in a particular function. You are covering like 3 other functions that you're supposed to break them apart and solve them in modular form. So that's what I want us to look at today's project. Then see how we can break them apart. Then tomorrow we'll just tackle some of the parts that we break them down. Then from there you can pick up. And I think I'm sure that you can tackle other problem from there. So already, I guess by now you must have read the material, gone through it. All right. Hello.
I can hear you, sir. We can all hear you.
All right. So I say I hope you guys have read through the materials, you make attempt. So today is more of questions. So I'm expecting questions from you guys. Okay.
Okay. Yes, sir. We've read through the material. Some of us we've attempted questions 0, 1, 2, and 3. But then most of us are not understanding the concept. We are just following along.
Okay.
Yes.
Okay.
Yes,
No
sir.
problem. So today we'll just break it down. We'll look at what exactly they are asking us to do and how to go about it. So if we are able to break the tasks into different modules, then try to tackle them separately, just the way we did for the previous one. So let me just look for a project from my own entry. So just give me a minute. All right, I'll be sharing my screen. Okay. So, guess everyone can see my screen, right? Hello.
We can see your screen, sir.
All right. So these are basically this section. I choose this section to start with this section. You understand? So you're writing a shield just the way you go to your shield bash, you type in command and it
I don't understand what's going on here.
open this one. Okay. So let me share this one first. So this a terminal already. This is a shield. This entire black space entirely this particular line where I can type in command is a shell. So that's what we're trying to write. So like if you say cd, I do this to take me to the root user. I can do ls. So this ls that I'm typing is the command. And once I press enter, this particular shell, this one that I'm working on, is taking in that command and is what processing it. So, and this entire this thing that he's doing is called process. So process is a command that is running at that particular time. So your machine takes in the process at a time. So even a process can call another process to be running and him waiting for that process to finish executing and return back successful message or error message. If that one that he creates, he passed the command to then succeed. So you can see there is what we call ID for each of those processes. So I'm working on something I can call David. Okay, David, handle this part of what I'm doing. And David will go ahead and handle it. Once he's through, I will be waiting for him, or I'll continue what I'm doing and allow David be doing, or I will wait for David. So that's where there is a command called waiting. So that's where you make use of that one. You wait for him to finish what he's doing. He gives you back the feedback, then you continue from where you are. So same thing here. So this command that I just now, that I press CD and I hit on this symbol, root symbol, it's not actually this shield that did this. He just looked through, but he a child that helps him to handle this command, this particular command. He creates a child, passing the command, passing environmental variables that this particular system is using currently. And he executes that particular command and return back what successful message. So that's why you see that this passed through. So let's assume I type in something like G, I hit enter. You can see he returned that what bash dash command not found. So this same thing, what this bash do is a process on its own, it's already running. So if create another process and pass it, he checks for this command, he didn't find it. So that's why he's telling me that what this command does not exist. If it actually exists, it will create a child process, pass him that command. He will help him to execute it. When he returns it back, if there is any return, the printout that he needs to do on the screen, he will do it, then return the successful error and successful message. And this one will loop again and give you what chance to pass in another command and still execute. So that's where looping comes in. So you continue like that. And if you want to exit it, you do exit. So based on the project, there are commands that they give us for exit. Sometimes you use what Control C. So, but based in this our project, they say that we are not to use Control C, you are only to use what Control D to exit the program. So that means you want to stop the looping. You want to stop asking it after executing this particular what command. You want to stop him from what asking you for another command. The program should stop. So what you are doing is you are creating a shield on top of a shield. So that's what it is. So like now we can see even this particular shield that we are on now, we can see its ID. Once we do let me see echo dollar sign, I think so. All right. So you
Sorry
can
for
see it.
talking. We are not seeing your screen.
You can't see my screen?
It was like as if the screen was paused. Anything we were saying or anything you were displaying was not.
Can you see the screen now?
Yes, we can.
Can you see 62?
Yes, I can see 62.
All right, so
I can see 61 now. It's okay.
All right, so let me zoom it. All right, so I'm just trying to explain the entire share program that we're trying to go into. So this 61 that you are seeing now is an ID. But the ID that is returning the ID of what? This current process that is running. Because we are on the process didn't end. So you return 60. If you still do it again, if you still repeat the same command, you will still see 60. Because what? We are still on that same what? Process. It's not creating another child process to do it. You understand? So if it's creating another child process, we'll have seen a different number here. It wouldn't have been the same 61 that we're saying. That's basically what it is. So we have to understand how child process is being created, and after execution, it returns it to the what? To the parent. The parent is the process that create that other process. So understand that's what process is. So once we understand what process is, let's move further. Let's go back to these. Oh. Sorry, I stopped sharing mistakenly. I wanted to switch tab. So I say we'll just pick some of them and just talk about them. So that's for the fork. So the fork basically what it does, it creates a child process and just passing command to it. Okay, I want you to do this. After execution, return back. So there's what it returns. We call it status. So once it returns 0, that means everything is okay. It's successful. If it returns 1 or -1, that means the child processing executes properly. Okay. So and it also returns, yes, it returns 0. That means it's successfully actually create and run. -1, that means it didn't actually create the process and it fails. So there are commands also. So free is still the same free that we know for allocation, for memory allocation, just the way we did with the previous project. We allocate memory manually. So after allocating the memory, we save some of the characters that we want to manipulate and the rest. So we are going to be doing this same thing on this task also. We're going to be creating what memory that will keep variables, because like I was explaining on this particular window now, yes, on this particular window that I just closed, let me show you. In this particular window now, we have what we call environmental variable. So each of the process has its environment variables. So you have like the path, the current path you are on, you understand. You have the user that is on the system. You have commands that you've executed before. You have you can also set variables for this particular part. So when you call this echo now, you say echo command. Echo is a command that is being defined. So we're going to be defining our own echo command in this project. So even also end of statement, we're going to be creating all of this by ourselves. So like echo now, once you create echo, you say David, like this, and you enter to echo out, to print out David. That's what basically this echo does. It collects the value, then pass it towards to the standard output. That's what it does. We've seen write function also in the previous project. So this echo, that's basically what it does. It collects it, then pass it to standard output if it's not piped in. It's not piped to any other function. So that's what it does. So, but if it is piped, so we need to pass it to that other function that it calls. So you can see it will create another child process to handle it. So So this entire window has what? Let me see. Echo. Do this. Out. Let's see. So you can see that this part that you are seeing now is a variable on its own. So and it's saved on my what global variables. So I have other this thing. I have user also. I can also see user from here. I can see sorry echo. Do this. Say for no mistaken. You can see. Okay. Let me see. This file user. I forgot this spelling, but let's try something. So how we do it? Yeah. Okay. All right. We'll still come back to it. So there are other commands like get current working directory. So you can also get the current working directory that you are on. So we're going to be making use of this also. Then get line. This one is very, very important. That's what we keep going to. We're going to be using to what loop through our what um, through the process as we pass in one command to process it, give us the output. After processing, it present us with another prompt for us to type in something. So get line is what we're going to be using to what get those commands the from the terminal. So get PID. So this get PID is used to do that same function, this same thing that I did with echo. So this is shortcut to do that particular function. So we're going to be doing the same thing. Am I sharing? Okay. Sorry, I wasn't sharing. So this is what I explained before. Get current working directory. So get line is what we're going to be using to what get the line uh, from the window. Then get ID. That's what it does. That particular command that I did. Then also kill. It kills a process. So even though the process is working, it kills it. Then malloc, we've seen malloc also. Malloc is for memory allocation. Same open. Open is to open what? For opening files. So, but here we're going to be using open directory. So for when we come to handle like directories, like CD into another directory, that's what we're going to be using. Then we have error. So this basically handles errors. So if you have particular error that you couldn't able to create another child process, or the command that you're calling for is not there, or the syntax entirely that you type is wrong, you have what? You have this to help you to handle it. So we have read. Read, we use it for files also. To read from what? A particular file. So read directory, then signal. What signal does is it tells you at each point of the child process what's happening. So it can either, so that signal that we're talking about, it can either return 1, 0, or -1, which is failure. So that signal, you need it. So at each particular point, when the process is created, it sends a signal, and you can also change those signals at a particular time. Then we have this start. This start basically is used towards to read the state of a particular word, of a particular file. So I think we have start token. star token. So this one is used to break a long string into tokens. So like you type in this command. Let me share this one. So you type in echo, then you say blah blah. Let's just do this and comma. We do another echo. Just let's keep it simple. So these two now, to once you are passing this, it's going to see it as what? As a single string. So you use tokenization to what? Break these strings into what? Individual tokens. You break them into tokens. Then you'll be able what, to handle them individually in what? In the command. And then let's go back to this. So then wait. I talked about wait initially when I started talking. So wait, what you do with wait is maybe I pass in this command to a child, this echo now. I say, okay, my child process, I want you to what? To handle it. Because if we are using the main program to handle these commands, if the commands fails, our project is going to what? Exit automatically. So that's why we keep creating what? Forking all these child processes so that the entire project will not what? The program will not exit. So like if we create this one now, we pass it to the child, we're going to wait for the child to finish and return to us. Then what he done, once he's done, then we continue from there. So sometimes you may create a child, and the child will still call another what? Child again. So you have to wait. Okay, wait for this one, or you can. We'll see the scenario where we're going to use it as we go on. Even if we are not able to face it today, tomorrow class, or when else we plan the class, we're going to see where they come into play. Now we understand their uses. So weights, ID, you have weight tree, they are just simple versioning. So you can see the write here. So this write basically is to write to the command line entirely. So to the standard output. So they give some tags to help you understand that okay, this is what these things are doing. So your shoe should work like this in an interactive mode. So what they are just saying that once you call your shoe, this you're calling the program here. What should appear is this dollar sign. So this dollar sign is there to what? This is a prompt. This entire place is a prompt. So once you kick this, so he'll take it and process it as a what? As a command. So this command we are seeing is saying that from being locate this particular word program and execute it. So and you know ls is normally to list what directories and files in a particular word folder. So this is what it's doing. So this one is just telling it what locate the command ls in bin folder and execute it. So the same thing. So we can see that by introduction of this particular word / is meaning that you should look elsewhere in another directory. So we can see even in this one, when we use for the normal shield, this dot means what? In this current directory. So we're going to be implementing these things also in our own program. So our own program should be able to what? Once it sees full stop, you should know that, okay, we are talking about what? Current directory, where we are working currently. So, and at the top here, you can see how we can get the current working directory. So these functions, we're going to be making use of them. So that's why each of these that they list here, there's where you definitely going to look at, need them. So then exit. So like I said, once you type in exit, you give it command exit, it should exit normally and returns back to what? To your normal, to your shield, the bash shield. So, but also in non-interactive mode, so that means if it's not in an interactive mode, the, this is how it's going to function. So in non-interactive mode, you are just saying that, okay, I don't want to remain in that particular program. I just want it to execute and return back to my normal bash command. I don't want to remain in that program. I just want him to execute this particular program and just do what I ask him to do. I don't want to go into it and interact with that particular program that we're going to write. So that's what it means, non-interactive mode. So just give it a command, he executes. You don't have a business with it. Let him just execute it and return back to you. So in this case, you can see that we are what? We are passing echo. So once you echo this guy, you pass it to it, he executes it and leaves it out. You can see that it's not remaining inside of it, it's returning to what? To the bash command. So same thing here. You can see in this one that we are interacting with it. Once we call it, we went into an interactive mode with it. You can see that he's telling us our own program that we've written. He's telling us that we're going to write. He's telling us that, okay, this is a prompt for him. You can see this dollar sign is for our normal bash, but for this one and this, our own prompt, telling us that, okay, we should type in something. And once we type this one, it's going to print out this one, then it's still going to continue in an interactive mode. When we exit, it comes back to this one. But in this case, you can see that in the non-interactive mode, we just echo out something from our normal system and we pass it to in the program. This the function of this is the use of piping. We call it piping. So we pipe the result of echo here to it. It receives this program now will receive it as what? As an input and execute in non-interactive mode and do this and return back to this and continue from where we are. You can see cards. So even this one too, you can cut this one and pass it to it. So this one is from files. Now you read, card, we use it to read what content of a particular file. So on a normal, it reads it and prints it out on the standard output. But now, instead of writing it on standard output, we are passing it to our shield program. So he's going to execute this first one, execute the second one. So that's what basically they are telling us that, okay, we should have it at the back of our mind. This is how our program should behave. So you can pass in two commands in separate lines for it, and it's going to execute both of them. So you're going to make provision for that. Execute this first one, execute the second one. So if you pass in something like this, you echo out. If you echo something twice like this, it should do the same thing. So you can see he prints out the files. The first time he prints out the files and he process this one. Because this content now is gotten from what? This test list file 2. This is a file, but this is content. So once you cut it, instead of reading it out, you're passing it to it. So he should behave this way. So we're going to see how we're going to make that happen also. So before we look at any other tasks, I think this is my own project that I did. So, but before we go further, is there any questions so that we'll answer from what we've seen so far, we've talked about? Is there any question? Hello.
I don't have a question, sir, and I believe nobody has a question. If they do, to actually raise up.
Please, I need questions so that it's going to be interactive. I don't want to be talking alone.
Any questions, please? Okay. I feel everybody's good, sir.
All right. I hope everybody's following. I'm not Making it difficult. I'm trying as much as possible to break it down. So I hope I'm able to do that. So that's why I'm asking. So because sometimes some people you're breaking things down and they're not understanding, so they'll just keep quiet instead of talk and bring you back so that you explain more.
Yes, we're following.
All right. So I really appreciate it. If you don't understand, bring me back so that I'll explain it in another perspective. Okay? So,
Excuse me, sir.
yes.
Somebody said that if you could explain the non-interactive mode again, that his network went off.
Okay. All right. Let's go back to that. This non-interactive mode is a very good idea because you're going to still be using them in other projects if you go forward. So understanding it is really, really good to understand. So let's say we have a program that is running. Let's come back here. Okay, let me share this. So, okay, when they say interactive mode, that means you are interacting with that particular program. That particular program has taken up a process. It's been mounted on your system and you keep giving it command, it's answering you. You are in that particular process. The process didn't create and just exit back. So you are inside that process is running and you keep giving it command and it's executing. So let's assume this particular window that we are in here, we said we did echo with this double dollar sign, a shortcut, how to get what ID of your particular process. And we did this and we got 61. So this is a particular, we are on a process now. So, and we can create another process once you call another program. Like this echo that you see is a program on your system. If we go under bin, we will see it there lying down there. It's a program that is being written. Let's go to a bin. Let's go and see it. You'll see what I'm trying to tell you. Let's see. Let me do it. Let's see something. Sorry. Let's go on thing this. No, not here. Sorry. Do this. Okay. Library. It's been shield. That's what I'm looking for. Variables. Boot. Okay, we have our bin here. Let me go into a CD into what? In. Enter. See, clear. Let's do ls. Here also. Let's do run it. Okay. So you can see there are a lot of programs under this bin. So depends on the one you call. Let's see, arc as so you can see cat is here also. I hope you people are seeing it.
Yes, we can see it.
Okay, you can see cat is here. So cat 2 is a program that is being written. And you understand. Let's do something to I'm looking for echo. It's echo that I was looking for. But you can see also cat. Cat is a file here. Anyone that is seeing blue here is a folder. So but you can see cat is a program. So calling it from there, from our bash there, giving it those commands. This is the program that is actually coming here to execute. So you can see also, let's see, I'm looking for echo. Where is echo? You see copy 2 is here. You can see copy here, 2 is here. Popular ones that we've been using. So you can see bit 2 is here. So you can see directory is here also. So you can explore these things. And these are concepts that they're talking about. So once you understand these things to tackle the our echo is here. So you can see our echo is actually here. So let me do something and say VI executable files. If they are, I won't be able to do anything with it. So but let's just try and see what is inside. Via echo, just see. So it's an executable file. You can see it's a code that is already compiled into what? Into zeros and one for execution already. You understand? So that's why you can't read it. You can see the way it is. You can't make sense out of it. Can you? You cannot. So this is what it is. Okay. So let's exit this guy. Just shift key. Let me quit it. Let's quit. So this is what I'm trying to bring your mind to. So let's go back. CD and just do this. Let's go back to home server and let's play more. So you can see that particular bash program. Once we call it here, it's going to be what? A process that we are calling. It's a sub process in this particular process that we are on. And we see that this process that we are on is ID is 61. So you pass this command to it, it's going to call another sub process to handle it. So in an interactive mode, we are still on this this particular shell, and it's keep asking us that giving us prompt. And you can see his prompt here telling us that okay, pass in another command, I'm ready to accept it and process it for you. So same thing we are going to be doing with our own. So in an interactive mode, this is what happens. As we pass in echo, say David here is going to execute it and still remain in that particular process. It's not going out of it. It's still handling that process. And if we check again, we'll see that we are still on ID 61. So that means it's that same process that keeps calling again. So we are in that particular process. So in an interactive mode, we don't want a situation that we want to go into it and stay in that particular process. We just want him to run that particular command, and us remaining, we don't want to even go inside and see what's happening. So if you do something like this now, you can see this and SSH bash. It's just giving an example. So this is a particular command that you are saying. So it means the inside the current directory, this you'll find this command. So like this being you go and find ls. So ls2 is lying down there. They have written the command, so you are using it. But now you are the one coming up with those commands yourself. You are writing them. So they are all inside bin. So this is how it acts. So in an uninteractive mode, you can see this, after calling this, our program that we're going to write, after calling it, you pass it this particular command, it checks into what your global variables. That means your where your program keeps what it files. So it will check directories that you have to go and check the bin directory and check whether ls is there. If ls is there, it's going to call in that ls and execute it, then comes return the value for you, the outcome of that program, and what continue. It will still prompt you. It won't exit. It won't go out of it. So same thing. If you say exit, that's when it goes out and comes back to your what your normal bash shield. So you can see in a non-interactive mode, which brings us to what you are asking that what is it? So this is what it is. You can see on this particular one, we are still remaining in what in our shield program, telling us that okay, yes, so I've executed this one for you. Okay, still give me another command. Let me execute it for you. It's still asking you that okay, I need more commands from you. Let me execute it. And you can see that they didn't enter anything. They just press enter. It just still bring you down here. You didn't do anything. So and here we pass in exit, then it exits the program. So that's what they are telling you that okay, if you write your program, you should act like this in an interactive mode. Once you pass in command, you should loop again and tell you that okay, pass in another command. If you didn't type in anything, you didn't pass any command, you should still go ahead and loop through again and ask you to pass in command. So you can see in the non-interactive mode, it doesn't wait for you. He's not inside here asking you for another command. Just go ahead. This particular what parent shield, which is the 61, goes ahead to just call the program, pass in the values, execute it out here, and what still goes back to what the parent. So this is a parent phone that we are on. This is the normal bash command that we are on now. So it will call your own, pass in these values to it as parameter. Just the way you are passing parameters to echo here. That's the same thing that he's going to do. So instead of printing the value on standard output, this echo as standard output, he receives it, the list, and pass it to this guy, and this one executes it and gives you this. This is the result. So it's going to we're going to define our own list command also to do that for us. Then it comes back to the parent. It doesn't remain like this one now. After doing this pin now, you can see after passing the result, it still remains on our program till we say exit, then it comes back to this one. But in an interactive mode, you just passing the values to it, execute, and come back to the parent. So and that's just what we mean by interactive mode and non-interactive mode. So it calls the program, it passing values to the intended program and execute it and go back to the parent. It doesn't remain in the child program. But in this case, you can see this is our parent. But once we call this program, we enter into an interactive mode with the child program. That's the child process. So we remain at the child process and we keep passing in information and the child process still remains. It doesn't go out till we say exit. Then it exits back to the parent, which is this one. So that's the difference between the interactive and non-interactive mode. In the non-interactive mode, it doesn't go into the child and remain in the child process. Just pass the command just pass the value to the command. That's the child process that is going to create and execute it and bring it back to you. So the same thing here. So I think if we are through with this, I would like us to start breaking the program down into, based on what we've seen so far, how we know about there are variables in our environment, how to get them, then the structures that we're going to be using to help us structure our program well, so that we'll be able to handle each particular part, like printing out, listing out, echoing out, CD into directories. All these ones, you have to break them down into separate parts for you to be able to do it. So I will give you a holistic view of it today because already we are taking up to an hour. So I have other things. So I want to just explain this the next 30 minutes. Let's break it down so that if you guys fix time for me again, then we'll go into the code. Because if I say I'm going into the code, we won't be able to explain it. So let's break the program down. Let's just create a file here. Let's just call it shield. Let me see if there is no any file here. So I will write some things. Let's list this directory. See what's inside. I have an issue, no an issue. So let's create a shield directory here. So make directory shield. And cd into it. CD into shield. Okay, so you can see we are inside our shield now, shield folder. Like this. So all these cd make directory, we're going to be creating them also. So based on the command we pass in, we want to get a particular function and come and execute it. If it's not there, you should tell us that okay, the command you are requesting for doesn't exist. If it does, you should execute it for us. So first thing first, we know we have environment. So we need a way of getting those environments, saving them in our in a sub process, creating that particular environment variables, so that we'll be able to execute it in the child program. So the first thing we are going to do, we're going to create our entry point. So I'm just going to give us the entry point, what we need. So let's say, our program always start with with a main function, right? So that's all programs, that's the entry point. Main always looks for that main and executes. So let's create a file called main.c. It should be basically our entry point. Then we're going to create the headers also, but I just want to put some things inside this. Oh, sorry. vi main c. Go in. Okay. So we are in here. So first thing first, let me just create. This is the normal standard. We say main open. Let's say this is going to have int and it's AC, comma car is the type of what we're going to be expecting. So I'm going to be expecting arguments. Okay. So let me see. Okay, how this guy open and close. Like opening and closing them before continuing. Oh, okay. Let's look at another concept here. You can see that this main variable that we created here, this main function, and that is going to be our entry point once we execute this file.
Sorry, we can't see your VI main, or is it just me? Okay, it just
Can
came
you see?
up. It just came
Okay,
up.
all right. So you can see here that this main entry is normally when you are writing it, you've been writing it in such a way that you just say void here. You mean that you are not going to pass any variables towards, let's say void. Sorry, I'm saying main again, void. So this void means that okay, I'm not expecting any value from the command line when I execute this program. So at the point of calling this program, I'm not expecting any value. It's just this program. Go ahead and execute this program for me. So if I say printf, I call printf, is going to print out less. try and see how they work so that it will give us more understanding of what is required of us. Let's say include. Sorry, you guys are going to be helping me out here. Did I do it correctly? I've been working on Python for quite some time now in PHP, so I may forget some syntax here. So you need to be helping me to refresh my memory. So include, let's say, we're going to take in standard input and output of each, I think, unless, is it right? So, okay. So we'll come out here and see what. Say printf. Then I will have something. Let me just see. Guy. Hello world. Just simple. Let's just keep it simple now. Just understand. Say hello world, but I want you on the next line. It's next line to be. This is just a simple program. We're just saying, okay, just come in here. We are not expecting any value in here. Just execute printf for us and print out this on the standard output. So printf will process this because printf is a program on its own. We've created our own. We see how it works. It's going to process these strings, call other sub functions, and do the work. And it is going to print it on what at the end it's going to print it on the standard output. So if we exit this, let me save this file. Save this file. So we say GCC. We're going to name it as say GCC main.c. I want to name it main. We name it main. So if I do ls -1, I can still find it. Okay. You can see the executable here. So you can see that functions that we saw there. You can't open it. Once you open it, they have already compiled it into an executable file. So that's why you can see it's even showing green here. So if we want to use this particular program now, we'll just say dot. So we are telling this shield that, okay, this is the command we want to execute. Check your current directory and what execute main function. So it's here. So he's going to check his present working directory and check for this particular function. And once we do this, you can see that we've called our program that we just write now. Just a small program that just prints something out. And it prints out on the standard output and goes to the next line. And he's still asking us that, okay, yes, I've executed what you've asked me to execute. I'm waiting for another command. And if I pass him another command again, he's going to do the same thing. Yeah, so this is what our program will be doing. So, but you can see here, what we did here is we are saying that, okay, this particular program, we are not expecting it to take any value. If we do this and say, okay, main, and we say, let me see, HR, let's give it, goals, give it silver. What you can see here is I'm passing values to this command, but he's not receiving them. He's not processing them. He's just going out to print out hello world for me. So in our command is not expecting any value. So that's why that void that we have there, we are telling him that, okay, we are not expecting any value from you. So if we do this, main dot C, we go back. So you can see we are not expecting any value from it. So that's why we put this void here. So that's why we're not getting errors from those particular input that we give. So let's go back and see how we can print out that gold and this thing. So we can do that by saying, okay, we are expecting a string, and just string here and just say car. No, we don't have string here. So we can just do car here. Yes. Let's see. So that means we are expecting a particular word string. We're going to pass a string here. And let's see, once we pass that string, we want to print it out also. It's standard output. Let's see, hello world. Give it a space and say, okay, expecting a string here. I'll say, comma, and I'll pass in the str. Let's exit this guy. See. So let's run our program again, compile it so that compiled. Let's get this guy. See. Let's call that program again. Say main. This time around we give it so segment faults. Okay, sorry. I'm supposed to read it out. Let's go back to it and say dot the main dot C. Go back to it. So here, main already has its own definition, so we can't define for main, determine okay how our main is going to function. It already have way it's going to function, so we are overriding it. So if we are going to override it, we have to follow its own syntax. If we want to pass in something to our main, there are two parameters that we need to define. The first one is an integer. So say int, what means is the number of argument that you're going to pass in, and you deal with something we call variadic functions. So variadic functions means that you don't know the number of argument that you're going to pass in during execution. So the same thing here. So if we are overriding a function, we have to do it the way it's being defined, because it's going to throw, that's why it's throwing that segmentation fault for us. So now, if we have this guy here, we can decide to check and print out the first argument from our terminal. So let's say, let's print out args open, say at index 0. So this is an array of an array, if you remember. So let's see what we get. Let's compile it again. So let me get this. And let's do this time around. We'll say main, then we'll say David. We'll see what will happen. It won't print out. David is going to print out this was. So you can see that it took in what we're able to pass this our entire batch. What it did that it takes all these variables and tokenize them. So that's what they are telling us, that they are giving us those functions, telling us that we're going to make use of tokenization. So the token, it breaks them down into two values. So once you receive them, the first one that we're going to get from that validated function is the first argument that is going to pass in, and this is the second argument. So we access the first argument. That's why we are not able to see that, okay, it's David that is passing out. So that's the use of what validated function. I'm going to be using it also in our project here, because once we pass in, we call it first of all in a non-interactive mode. This is what we're going to be using. We're going to be using the validated functions. So in an interactive mode, we're going to be using the looping. Is that understood? Let me repeat it again. In an interactive mode, we're going to be using what we call looping. We're going to be looping. We're going to be reading the line, read line, read line, read line. But in a non-interactive mode, we're going to be using this variadic function so that it will what? It will receive these values in a non-interactive mode, then process it for us. That's the way here, what we just process it in such a way that, okay, you just print out hello world for us. We didn't do anything big. So that's it done. Let's go back into it. Into this. So this is a file that we're going to be creating. I'm already structuring the project already, if you're following. So take note, this main.c is going to be our entry point. So I'm just trying to explain what these two are. So we can see that, okay, if we receive these two guys now into our project, we're going to be able to receive long values. So we don't want to be limited to one value. So main will help us tackle that. So what this does is it prints out the number of argument that you pass in through this. So if we want to read all through the value, we don't want to go into segmentation faults, just the way we faced the other time, the last time. So we're going to use this because this is going to return the number of argument that was actually what passed. Because the way it counts the argument is by space. Any space that you give, counts it down. Okay, the next value that is coming in is an argument. So it counts it and keeps it in here for you, so you can still access this and manipulate these particular values. So that's the use of these two. So, and we're going to be using this variadic as what? In non-interactive mode. They help us in non-interactive mode. So if it is the interactive mode, we'll have just gone through it and just prompt a user, okay, we want to read your command. So this variadic that we're having here, its basic function is for that non-interactive mode. So let's structure the project. Let's do this. So let me write some things down here, then I'll explain. We'll go back. We'll see how we're going to tackle it. So DD. This particular line. I don't need it. Yes. Submit. All right. Can you guys see my screen?
I can see your screen, sir.
I'm having network issues, so it's kind of cooking. Slow. So I'm trying to enter into insert mode. All right. So the first thing I would like to do here is I would say I'm going to create a structure that I'm going to keep the values of my current environment. So I'm going to call it data shield. So I'm going to name them. So we're going to see them today, all of them. So I'm going to have I'm going to want to collect my signal at each point the child process that I'm going to create. I want to know what the signal that is having, and I'm going to pass it to the normal signal handling to my shield. Then I'm going to set the data for these particular environment variables. So I'm going to use malloc also in creating saving that particular data in another separate data structure to be able to handle it separate from this current program that is running out of its environment. So I'm going to create my own. Then I'm going to create a loop, that's shield loop, that is going to be looping around, looping through. So if this signals that okay, this particular function is not for looping, you just execute it and go back. And I'm going to also free that particular data. So let's see. Let's write it. No, sorry. So the first thing I'm going to do, I'll name it. Let me name this particular data structure that I'm going to keep my values. Say shield. So this is a data structure that we're going to define, but we haven't defined it yet. So I'm going to give this, it's just variable I've defined. I won't pass the value yet. But this is a data structure that we're going to define ourselves to help us keeping the data for a particular shield that we are in, so that we'll be able to change the status of a particular process that we are in. So the next one, let me see. There is something that whenever you create this, you have to make use of that particular function. If not, it's going to throw an error. Why? It's not error per se, but it's a wastage, because now you've created a function and you didn't make use of it. I put checkers when I was doing compiling. I did that deliberately to see that if I put those tests saying that, okay, check error, check indentation, and check the rest, those particular dash that we put, and check error, check what again? I think there are up to 4 that we check. So I do that, it will throw me error because I didn't make use of this value. So in your own case, you have to silence this value, saying that, okay, yes, since main is forcing us that we're going to receive true value based on his blueprint, that this is how his blueprint is. Either we use the one with void or we use it like this. So there is no one that is going to take only this. So these are the 2 blueprints for main function. So we choose to use this one, but we are not interested in this value. So to silence this one, so that we will not get an error, we have to use this. We say void. So we cast, you know what they call casting. So we cast this guy to void, AC. Say, okay, now you are void. You are casting it into void. So that error is not going to come up because we are saying that, okay, we make use of it here. So the next thing that we're going to do, there is what we call signal. So the signal is also part of standard and universal standard library. So we're going to see the use also. So we're going to just introduce some things here. But don't worry, we'll define them once we enter our header file. You're going to see them there. I'm going to be making reference with it. So this is it. So it's global, this sign int. So the sign int means sign integer. So it's going to take it in and keep it in this particular. So we're going to define a function also. Get sign int. We're going to define this function also if we go forward. Then after we've received we'll get the sign, okay, what's the process? Did the process fail? If it fails, this signal should handle it for us. Exit the project or whatsoever that he's going to do. Okay, pass the control back to what? To this parent project. So it depends on the signal, what the signal is at that particular point. That will determine what will happen here. So we'll say set data. So we're going to define it in this particular main file also. We're going to see the definition. We'll say main data and set data. So we're going to take the location of this particular this data bash here. So this wall is going to do the saving for us. So we're going to save it here. So this one is just to save the data bash for us. So let's take the location where this particular memory is being allocated to us and pass it to this guy. So we want to receive it there. We'll define it also. And we pass in what? AV. So this AV that we're passing in is going to come from our definition also in the header file. So it's an environmental variable that we're going to be handling. So let's call them here for now. So we have also shield. So this is our main shield loop. We're going to be defining this loop. So it's the one that is going to keep iterating for us. Going to keep iterating as we are calling. It's going to be iterating. So this loop, what it does, it takes in so let's take in the address also for this bash. Passing the environment variables also. So it's going to have its own environment separate from our parent environment. So after setting that, then here we're going to check if data that we have in this guy dot status. You understand? So this is a structure we are defining. So inside that structure we have what we call status. So if the status that it has is less than 0, that is went into negative. I told you that once a process returns status, it's negative. That means it fails. If it is equals to 0, that means it creates that process successfully. So the same thing here, we are checking, okay, this particular process that is going to be created here for us and the environment. So we are checking its environment. Was it actually created? If it's actually created and is successful, it just wants to return. We just return to, I think in the project they asked for 255. I think so. But let's use it here. So what this returns is also a success. Is an error figure that we're going to send back. Is a process number that we're sending back. ID, let's say an ID. So because immediately a process finish executing, it sends back a number. So if it is an error that we got here, we want to send back that error as a signal also. This 255 that we're going to use. So, but in the case that it didn't fail, it actually went through. Okay, let's go here. So if it didn't fail, so we want to get the signal, the status of this guy, which is going to be either 1, 0, or -1. So since we've discovered here that it's not negative, So it's not less than 0. So if it is 1, we want to return it. If it is 0, we want to also return it. So just return the status back again. So our program will keep looping. Once he finds this one, the status is okay. It keeps looping. But once we return this guy, we're telling him that, okay, no. The program is what? We are not able to what? To create, to fork another child process. Stop there. So let's go back up here and do some kind of little definition. Can you still see my screen?
I can see your screen, sir.
Okay. So let's go back up here and define this particular set data that I made mention of here. So we're just going to say void. So the set data is not going to return anything for us. So we're just going to set the data, and we don't want anything in return, just to help us set. So we just say set. Sorry, I'm doing this now, but we'll go into the header. So we're going to take much time in the header doing some things. So I just want us to round up this one here so that when we go to the header, make reference to this. So this guy too, these blueprints, I'm just using them here. I'm going to define them in header when we go there. So help me remember these things. If you can be jotting them so that I will ask you, so that we don't have to be going back. So set data, I'm going to take in data shields. So I'm taking data shields, which is the data type. So it's going to be what? A string. Sorry. Let's see, data. So it's going to be a string. I'm going to take a car, and it's going to be what? A long variable that we're going to be passing it. So yes. So it's a string that we're passing, a string of string, double pointer. So we're passing that to it. Okay, what next? We have this unsigned int. This unsigned int will help me to assign the status for this particular environment. So each time the status changes, I want to change the environment so that from the environment I will be able to have the status. Let me use unsigned int to be at the safer side. Signed integer I. Let me just name it I. And come down here and see this data batch up here now that I pass in here to this guy. That I'm passing in here, I'm going to use it. He's going to have what we call AV. So you know his attribute that I'm accessing here. You've seen this, right? So let me make use of it and assume that you've seen it. So it's going to take in this. I'm going to set this one too. So you can see how I'm using it. It's a data structure that we're going to define. So I'm already using it before defining it, but let's put this input as null now. So this particular input now that I'm going to be doing, I will explain it later. But this input is going to be keeping all the arguments that we pass through our validated function, our main function, those values that we receive there. That's where we're going to be keeping them. But for now, as it is now, once we are setting it, at the point that we call our loop for the first time, I want it to be what? Empty. So as it's looping, we're going to be updating it also. We're going to be changing it from our data structure. So we have also again this H. Let's have arguments. So arguments, let's make them null also for now. Null, then we have the H. Then our status, our famous status, what I like because we're going to be using it a lot. It's going to save us a lot of stress. So, and it's going to give us hint of the status of our project at our share at each time. So I'm going to keep track of how many processes are running. Is it just a child process that is running? Because at each point that we're running, so we're going to have one. So we're going to be changing this. If a process that we created, a child process, creates another child process, we want to be updating this counter. So it's going to be keeping track of how many processes we've created. So we know that, okay, at this particular point, we have only one. So if we have only one, that means we are at the parent process. So if we have like 2, 3, that means there is some child process they are running. So still going to be waiting for them, but it's good to have it, save it, because there are some situations that we're going to be using them in some functions that we'll be creating. So it's good to have them. So here now, after doing this, null here and our arguments, they are null. So what I want us to do, I iterate over what we call environment. So there's a general way of getting the environment variables that you are having. You see that time that I say echo, then I did $sign, I put part. That part that I did, I'm getting it from global variable. So that variable, we can get the entire document of it. I try to access user. I don't know the spelling for that particular user, how they save it, the variable. So, but we're going to see it here. So we're going to access it. So to access it generally, there are 2 ways you can access it. You can either access it through the environment variable, or you can pass it in through your main file. Or you can import it, directly from a library. So, but I'm going to get it straight here. Let me make use of it. But when we go to our header file, we're going to impute it there. So you're going to see me using it. So see for I that I defined up here. So I want to initialize it here. I can initialize it outside, but let me initialize it in here. I'll say that environment. So I want to iterate through it, through each of the lines there in the environment. So it's going to give me in lines. So I will say I first index. I want to see the total number of it. Say plus plus. So what basically I'll be doing here is just to check how many values, the definition that we have, global variables that we have in that particular process. So by doing this now, I'm just going to iterate and set the value of what? I. Okay. So this is what is going to do. What I'm saying that this for, you're not going to execute any other. This only thing that you're going to be executing. So I can either open or close, but it's going to throw me error. It's going to tell me that empty parentheses. So this is just a shorthand for saying that, okay, I want to count through this and know the total number. When you started, they asked you to count the total number of characters in a string. So this is another way of you can even do that also. So, but here I'm taking advantage of that to count the total numbers of global variables that we have in our environment that we're going to be using. So why I'm doing this, because I want to transfer these things to a safer place that I'm going to be using, because if the parent changes its environment, I don't want it to affect my child's environment. So that's why I want to copy it, this first place to that place, so I don't have any hiccup there. So the next thing that I'm going to do, I'm going to say, okay, I data shields dot what underscore environment. So I'm going to have my own tool that is going to save it inside now. So you can see my own, I'm defining it as underscore environment. It's the same spelling, but now I'm adding my own, so I don't want it to clash with the global one. So I will say malloc. So you can see malloc will come to play here. I would like to assign a space so that I'll put these guys, they are going to be in a string. Each one of them is going to be in a string. So I'm creating a space for it so I will say size of car, which is just a string. So I just want to know the size of a string, then multiply it, just a particular word, character. I want to know the size of a particular character for any machine that is going to run this my project. Is it a 62-bit, 32-bit machine or 62-bit machine? So whatsoever. So that's the use of this size of. So I want to know the size of character for that particular machine. Then multiply it by I because I already know the total number of words for that particular word strings I'm going to be using, characters I'm going to be using. So I'll say I multiply. So I'm going to add one so that the new string I'm creating is going to have a null ending. So end it guy here. So since I've created this, I also check if my malloc work, fine and good. If my malloc did not work, I want it to be exited. So I don't want the field memory assignment that my system couldn't allocate memory because there is no enough memory. So I want it to fail. So, but since I'm doing it, we're going to check it in our header file. So we won't check it here. Let me just make use of it here. So once he's calling this, it's going to go to my header file and do that calling also. So I'm going to put a check there when I'm creating this data type. So, but normally we'll say if is data hash equal to what? No. So just wants to exit. So in this case, I don't want to do this. So I'll just delete this. So I'm going to say for I equals to 0. I've already achieved what I want to do with I here, so I'm at liberty. I can still change I, or I can create another variable that will do that. So, but I'm already through with I up there. I've achieved the aim of using I here, so I can change the value and still use it here again. Because once I assign it 0, its value changes here to 0. Because if I continue with I here, that means the value that it has here is still maintains it here. Because it's what? It's a global variable. It's a class variable that is defined here. So let's go to the see. Equals to 0. Let me say environment. So now I'm going to be accessing the values from that environment now. So I'll check. Because environment has a null termination. So once it gets to the end of it ends with a null value. You understand? So even here, I know some people will be asking, why did I add 1? Since the total number of the characters here, the items here in this environment is I, the value of I that is saving. So why didn't we assign that particular number? So we are adding 1 to it to give us space at the end to put a null to mark that, okay, this is the end of what our search. You can see even in printf, during that time that we're creating what a structure that keeps all the functions that we have. You can see we create a one that has null. So null basically is for us to what be able to say, okay, this is the end of it. So that's why I added one here. So you're going to see the use where I'll add the one also to it. So, but once it gets to null here, this guy is going to keep iterating. Once he finds out that this guy is null, he's going to stop. So I'll say I plus plus here. So this guy, open this, go to this, say my data shield. So I just name it data shield. You can name it whatsoever you want to name it. So I think that this is just the one that I will come up with. I think maybe you have a better definition than me, so you can use it. Underscore dump. So the star dump, I'm going to define it also. But let me make use of it here. So it's going to dump it, duplicate it. So it's a string duplication. So I want to duplicate it and I want the one from the environment itself. Just duplicate. So I want my my child's environment to be clean. He should be working on his own. I don't want him to have anything to do with his parent. I want his environment to be intact, to be running on his own, without the influence of his parent. Because once I'm using the parent's variables and other things, if the parent changes variable, it can affect my child process. So I want to make his own isolated environment for him to run in. So that's why I'm going this route of doing these things here. So have this here. Yes, end it here. So once this guy is ended here, so you will see where I'm going to use this guy. So I will say data hash. So that same environment that I allocated the memory for here, you can see that I added one back and I've used it here now. I check first to see the total number here before creating, then I come back here to do what they are assigning. So I know the exact number that is going to come in here. If it is 0, this guy is going to allocate 0 memory and is going to pass in null at 1 that is going to create. So I know exactly what I'm doing here because I know that it's going to return what the total is that number. So I know that, okay, since it's returning that, I know I'm going to have those values ready. So I assign them to this guy here. I dump them as strings here. I duplicate them and dump them here for each. So it's going to be the same replica for that environment and values. So I would say underscore environ I. So once this guy comes in here and find out that this guy is null, it stops. So I is going to remain as the end value of that. So I still has that end null, but our string here collected just Please, if you are following, if I make mistake, call me back. Even if I don't see this now, it's going to be a big error for us. So this now is going to be the last value that this guy filled. So I want to pass null to the end because here in our value we have extra one. So I want to pass it null to it. See null. Okay. Then I'll say data shield dash ID, PID, that's the parent. So I want to keep track of my parent's ID also. So this is where I'm going to save it in my what data. So okay, say equals to what? So we're going to have what we call that. Should I do it now or do it later? Let me do it here. Let me just say auxiliary is to transform it into what? So there is a function that we're going to create. ITOA. So what that function does is, even in shell, I did one command. I do double $sign. And it returns what? The parent function. There is another shortcut that once you do, you get a child process that is executing that particular echo function. So in this case, I want to keep track of that particular function also. So that's why I'm keeping this guy here. So when we call this function, so I'm making use of it here for the first time, but you're going to see it when we are defining it. So I'll say get PID. So this function that is saying get PID, I'm going to also define it. So sorry, I'm doing so many definitions here, keeping so many functions here without. So I know sometimes it can be confusing, but once we start assembling it there, you'll see how it comes into play. So I think since we have this one here, the next thing should we go into that? Okay, should I define it? Let's define function that frees up our data, because you know that we have so many we did some allocation here. So, and if you can see here, inside this place, sorry, I'm just thinking of how to structure, combine it too much. That won't get hooked. Okay. Let's do it this way. Let's define the free up memory for this particular guy here. Let's define it here. We're going to be making use of it in other programs that we'll be executing. So let's just define it here. Let's go back up. Go up here. Let's see. Okay. So let's go back up here. I'll define it as void. So it's just to free up these memories that I'm going to be calling it. So there is a lot of functions we're going to be creating. See, this data, once we pass this particular data, once we are through with it, I want to free up the space so that I won't have garbage in my project, or I will run out of space. So my program is running. It will help me to curtail that. So whenever I call up free data, you know that this is the function I'm calling. So I'm just going to pass in this guy. I'm not going to accept this. So I'm naming it like this so that you know that, okay, this is the guy that I'm calling. So this is the first place that we do it here. So that's why I'm keeping that same naming convention. So this is just a parameter. It's not the actual argument. So they are not the same. This is a parameter, not the actual argument. But there it was the actual argument in the main function. So here I'm going to say, let me keep track of unsigned int. Let me do unsigned int. int I. Okay. So what I'm keeping this is to also iterate to see, okay, what are the numbers of items that I saved inside the environment, and also the other items in this data structure that we're going to create. So I'm going to say for, let me initialize my I here to 0. Yes, 0 will do for us. So let's call environment borrow. So in this guy, I'll say I plus plus. And then this, open this. Okay. So no time is kicking. We have, and want to stop by 11. So we have less than 15 minutes. Let's try and cover this so that we'll do some this thing in the header file. So if it comes here, as it's iterating through, I want to be freeing them. So let's say free. I want to get this environment. I'm yet to create. Create logos once I've created. So you can see here when I'm doing the settings, I'm adding them. And see, I'm adding them here. I'm adding some kind of values. So like this one now, since I'm creating the environment here, you didn't see it because I'm not setting it here. I'm setting it here, sorry. You can see it's just the environment that I'm doing that. Since these ones are primitive data type, I don't have to deal with them. So you can see I will do for also argument also. For PID, because here PID I did what? Yes, here you can see I did auxiliary, I say get ID, I pass it up here. So it's going to allocate a memory space here too also. So I need to split this one also. This is going to be creating memory space before we have memory leakage there. So in this one here. So this will do. Okay, I see free this dash this must go arrow. So after doing this, I'll clean up the environment itself. I went inside each of those strings that I keep inside this environment, I clear them. So the environment itself is a memory space, so I want to clean it up also because I allocate a memory space to it when I'm doing the setting of this variable. You can see where I did the memory allocation here for the environment itself. I allocate memory. So inside that memory, I also save what? Some strings also inside. So I did, okay, here you can see I was saving some strings inside of it here. So those strings are the ones that I clean up. So after cleaning it up, I need to what? Clean up this guy itself. So that's what I'm doing here. So cleaning up this, clean it up here, then let me clean up my PID also. See. Let me clean it up also. PID. So this will go a long way. Let me give it double space here. Okay. So I think so far so good. We are through with this particular part. So we're going to be defining this get sign int integer. For this signal, we're going to be defining this sign int. Okay. Then what again? Set data, we've defined it up here. So I just want to do away with this for now. So, and also the free memory, we're going to be doing it because as these guys are calling it, it's going to be what available here in this particular place. So as those programs are available, I'm going to be having that free data also, be calling it at my disposal. So let's go to our header file. Let me clean up this. Delete this here. Don't actually need you here. But before I do this, what should we name our header file? Hello? Hello? Hello?
Hi.
Well, yes. Well, yeah.
I'm scared. I'm talking to myself already. Hope you guys are following.
Yeah, well,
Yes.
fine.
Seriously, if you are not understanding anything, please draw my attention. Let me explain it more further. Okay?
Okay, I think somebody's raising up his hand.
Huh?
I think somebody's raising his hand or maybe have disabled.
All right, please go ahead and ask your question as I'm making the final tidy up before we leave this place. Please ask your question.
Maybe have disabled. Please ask your question.
Please go ahead. I would really like your questions, please. Let's just name it main.h. Please ask your questions, please. This will include our header file. They will have us. We are Gucci. We are good. We are good. Can we go ahead?
Yes, sir. Go ahead. Go ahead, sir.
You people are not asking questions. I feel like I'm not explaining well. Please ask questions.
Really?
All right. If that's the case, so that means you can see here I'm main.h. So that's the file that we're going to be using as our header. So take note of that. So now let's clear this. And see ls. Let's see how our directory is looking now. So we just have one file, which is main.c. That's our entry point, and we'll define some values here. We did get also. So we define get PID. So let's define that first. Should we define the stardom? Okay, let's go ahead and define our structure first. Let's define our structure first. Okay. So let's say main bi end of each. First thing first, to make sure that this guy to avoid double quotation import. Double import. Let's see, if defined. Please, can you mute if you're not talking? Hello.
Bolaji, please mute.
You're not talking to us. Can you mute? No way. So if not defined, main. So we want you to define it, include it. So define, some letters. Define main. It's not defined. We're already conversant with this syntax, so I don't have to explain it. So here, in my head, I love importing all my standard libraries here. So there are some standard libraries that we're going to be using. So I'm going to be explaining why I'm importing each library into this particular place. So each library has its use. So let me say, first of all, I will import my standard, my favorite class. Include like this, everyone's favorite also. The standard input and output, which I earlier made use of. So but let me import it here. That's why I removed it from the other file. Since I'm already importing the main file into it, so it's going to be available there also, since I'm importing it here. So it's going to be available. So this is how I like structuring my code when I'm doing project like this. And I find it very nice to be using it this way. So I will encourage you to also. Any import that you think that is going to be used across your entire system, that almost all files are going to be using it. Just import it in your main. It's easier that way than keep writing it in different places. So that once, if you are changing it, you just change it in one particular location. So like our main here. So the universal standard, UNIST. That's how it's spelled, not the other way around. So you know this universal standard basically is for malloc and the rest. So that's it. Varidic. We use it for Varidic also. Okay. So that's why I'm importing it here. Make use of. You can search it up in man. You will see it there. So standard library is the one that we use for malloc. So I'm going to import it here. You can see that I use malloc there. So I'll import it here so that it will be available there. It will throw us error. So include. Also, I have what we call system type. So it's basically for processes. So I'm going to be needing them also here. So you can look up these things also. I think when you are doing your reading, they introduce it to you. So it shouldn't be strange that we are using them here. So I made mention of weight also. We saw it when we are going through those functions. So this is how we import weights. We're able to make use of it. Good. I have error. So error, what error does is helps us to handle errors that our file, maybe we didn't see the command, so we need a standard way of handling it instead of just printing it out on the standard output. So there's a library for that. So we're going to be overriding some of those functions. Do it more elegantly. So there's this function ft. What is this spell? Can anyone remember it? Which we sorry. For fucking sorry is for to create another child process. TTL. We'll find out. So let me see this MTLH, if I'm not mistaken. CNTLH. Okay. Reports. So we're going to need it. Yes. Not needing it, I will still come back and remove it. Yes, import it. I'm not sure, but we're going to need it. If at any point we didn't make use of it, come back and remove it. We're going to need it. So let's do this. Include signal. Yes, we made use of signal. So include, and last but not the least, limits. Now a big signed int. So this is where it comes from this limit. So basically there is limit for the there is maximum number that ID of a process can have. So all of those, when you're looking for maximum number of integer, maximum number of float, maximum number of character. So here you're going to have it. So that's what this limit library does for you. So I think I'm going to make use of it also. So these my definitions I'm going to do. I'm going to define my own values, also global values that I'm going to be using. We're going to be using. I'm gonna say size. Let me put it 1,204. Yes. Let me have another one. Let me define this one. So define token size. So the token that we're going to be tokenizing, we're going to be splitting our code into some tokens. So I need to put it in a buffer here. I'm going to make it a maximum value. So once I call this, I know it's 100. You can go to your dial printf and modify it, because there we didn't make use of all these things. So but here, when I'm doing this one, I try to make use of these definitions my own. I think they are very nice for you to define some kind of constants that you're going to be using it throughout your program. So it's good you put them here. So let's define, because we're going to be using delimiter. You can see in some case where you can call two functions at a time. Let me show you something. We'll come back to this file again. We'll just explain something. So let's say we want to create a file at the same time, open the file, or we want to create a directory at the same time, enter that directory. We can do it in a single command. Just look at this. I can create a file called what? Touch. No, this one. You know, it give you what I want to explain. Let's say I want to create a directory, at the same time move into that directory. You can do make directory. Make directory. Then give the directory name. Let me say SH. And I can end it here. And at the same time, this is a particular statement. This is one statement. So after this, I want the shield to again move into it, to CD into that particular directory. So I'll say CD SHI. Doesn't exist yet, but once he creates this one, I want to enter into that shield. So you can see that I'm doing two commands at the same time. So there are delimiters. So these are delimiters. So I need I keep my delimiters where they will split these guys into different tokens. So this will be a token on its own, this will be a token on its own. So I will handle them separately, one at a time. So if this is a delimiter, if I try this, see what will happen. It creates a directory. At the same time, we enter the directory. You see how it executes those two commands at the same time. So delimiter, I'm going to be storing these delimiters also because I'm going to be making use of it. So it's just to show you that, okay, this is possible. And our command also is going to be doing this also. So you should know that. So cd, if I do dash, so you're going to implement this one too. It's going to take you to previous command that you did, previous directory. So it takes us back. So let me just remove my directory dash. Remove recursive XHI. So I don't need it. ls. Let me see my directory. Okay, it's clean. So let's be into our main.h. Let's continue. So I'm just showing you what I'm trying to save here. So I'm trying to save a delimiter here. That's why I want to define them here. So once I call delimiter, I know that, okay, it's for this token I'm calling them. So let me see. Delim. So it's going to be a string. It's going to have space. So a space also inside is going to be a delimiter. I have tab. So if somebody gives a tab, I want to make it as a delimiter. If somebody gives carat return, I want to give it as a delimiter. If somebody gives me next line, it's going to be a delimiter. If somebody give me a, it will be a delimiter also. My delimiter. So you can decide to change it any delimiters you want. So these are the ones that I'm going to be using. So that our environment that we make use of, I'm going to import it here. Sorry. Now our environment that we're using, let's import it. So this way of importing it, extend. So I'll just extend it from here. It's a character dash. Now, going to get us our environment here, globally. So that's how this is the advisable way of you importing those environments. Don't import them directly from the file. You can do that, but I would advise you to do it like this way. It's more clean and also keeps your code one place. Once you are reading it, you like to be nice. So let's define our structure. That data shield. So let me see, the first one I'm going to do, let me say type define. So because it's a type, I'm going to deal with a name to struct. So it's a structure. So let's name it data. Come down here. So we have made use of this in printf function. So we are not new to it. So you can see where I'm getting those guys. So here, AV. So that AV that I make use of, I initialize it to null. It's here. I got it from car. So I think I should have, I did input, right? I said I'm going to be getting it from this guy. So I did also this. Have arguments that I'm going to be receiving. I think I did it also in main. So let me see int. Status, yes, my favorite. So status, I'm going to leave you out. So I have counter. I told you to count my process, right? Processes. So I'm going to see them also happening. So I have car. So my framework environment that we used and also define methods to clean it up. So to have car, I want to save. It's going to come as a number. That PID is a number, but you can see that we cast it into strings so that we'll be able to save it here. It's going to be easy for us to manipulate it in strings. So I think those are all the ones that we defined, right? Let's check. Sorry. You guys save it then. Can someone help me confirm? That data structure that we did. Hello? Hello? So the structure that I defined the other time, that data shield, that DA2AS, are these the entire variables that we defined there? Or there are still some that I've forgotten? I'm leaving out. Can someone help me confirm? Let me just check. Okay, that was all right. Well, let's just check. Let's see. M.C. Let's just check. Be sure. Check together. So I have the AV. I put the AV, right? I put the input. I have argument. Also have the status. Yes. I did counter. Yes. I did the environment here. Yes. Then PID. Yes. So I think that's all. Nothing. Yes. Let me see. Okay. Yes. So we're good. Let's go down here. Okay. So our structure is being defined. So when you are doing your own, please try and document it. Put some document writing here. Because even me, after doing this now, if I come back to this, even as I'm writing this now, I know it's going to be, but try and document yours. So let's give it a name. Then we say data shield, define it as, I think that's what we call it. Let's give it P. Data shield. So, yeah, other structure will be defined in, but for now, should I define? Okay, let's define the built-in. So each of our built-in that we're going to be doing, each of those echo, cat, and the rest that you're going to be seeing, copy and the rest, they are built-ins. So what built-ins means is just built-in functions. So we're going to define our own. So functions that come with your word, with your system. So that's what you mean basically built-ins. You'll be hearing built-ins. So they are just functions inside there. So our own, to let's name it built-ins. So we're going to be defining our own. So let's have a structure that is going to be keeping them. It's going to keep their name and also what returns what the function that has it, just the way we did for printf. So once you be able to wrap your head around how to structure a program like this, you keep seeing them the same kind of way and makes life easy for you. And this is my biggest part of the program, that when I discovered this and I keep trying it over and over again, I was able to start structuring program. It makes life easy for me. And there are other parts that I keep applying this thing. So I will advise you to learn how to structure a program, because when you reach out to me, I think that's the particular aspect that you're getting it wrong. Because if you didn't structure it well properly like this, solving it is going to be difficult. So well-structured program is half problem solved. Okay, so like this now. So let's define the structure also again. The data type. Let's say type define structure. Let's call it built-in. Built-in. Then I'm going to call it what? So we're going to have name for it. The name should be what? A string. So name. Then have int. Let's call it shield. So it's going to return shield for us. Going to take in this function is always going to take this environment. You know, I told you that each of our process is going to have its separate environment, right? So this is a function. Each of our functions that we're going to define, they are going to have this kind of blueprint that they are going to be taking in what this particular structure that we have, because this is an environment. I want them to have their isolated environment that they are going to run in. So they are going to be taking this particular structure and they are going to make use of it. So we don't know how they are going to make use of it, but that's how I visualize it, that they should be having this kind of what structure. So they have his name here and we have what. So it's going to be a linked list. So you can have them, you can link them together. So we have a linked list and the first command, second command, third command. You understand? Just the way we did that one double. So once we find out that there is a comma in between the values that they are passing, we know that okay, it's a what? It's a chain of commands that they are trying to pass. So we're going to what? Link these guys together in this building. So this building is going to have the next one also. So we keep it here, it returns it for us. Can use it to check its name. Based on the name, we return the command. So let's put built-in here. This structure is going to help us do that. So let's name it built-in T. I think that's the convention. Most of these things I'm doing here, they are just standard of the way they do the standard. So I'm just trying to replicate it. So if you do some research, you see that this is how they. So this for this one. So, which one should I do? I did start dump, right? So let's define start dump structure. Those ones that I called, let's do them here. These two structures that we have. So let me see. Duplicates. Yes, it's going to return a character. You know, I have a function like that I call, right? When I was trying to convert a character, so it take in a string also. I want it to be a constant. Then which one did I define again? I think I defined get. Please tell me the functions that I defined now other name. We'll go to one by.
Good now.
Those functions that I make. Okay, I did get sign. I know I did auxiliary. Yes. So let's also define it here. Let's give the blueprint here so that we won't be getting error. Yeah. binary. So all of these, we're going to define them in their separate file. So it's going to take an integer n. So I think that's what it took there. Integer. So, what again? I think there is get signed in that we make use of it. So that one is just going to be void. So let's get this guy and assign it. Assign it to a particular word. This assign integer. I think that should be it from now. Which one should I start going with? I'll define the okay. Get line, shall I do get line now? Please. Sorry, trying to do something, just think through it. I think we make use of shield loop. Since I'm going to be looping, let me define the loop here. Let me give loop also here. So I'm going to return limit. I just want you to keep looping through. I did not see anything about exit. He didn't give passwords exit. Looping. Let me go there and see what I did so that I clearly come back to force. See, yeah. So we define this structure now. You can see that we went there and defined the structure. So you can say I was using the structure here. So we defined it here. We are not making use of this, so we make it void so that we won't have error. And signal, okay. So there is signal. So we need to define this signal. So get signed int. I have given the structure, right? So he's going to just get the signed int and pass it here. Then this guy will take this one, assign it to assign it to our signed integer at the background. So it's not going to return anything. Set data, we've defined it up here. So it's just going to set the data. Not going to return anything. So I need to, since it's already up here, it's going to be available to this guy here. So I don't need to really define it there, but I'll still put it there as a blueprint just for clarity. Then shield loop, I've made use of it. Okay. So this data, the status is to just get my status and return it. Then what else again? So I'm returning to 555. Okay. Should set data signal. This kind God, another one. See. Signal. We're already using signal, so you can look up these functions. Like this signal, you can look it up. What it actually do to this get signed int. So just pass it signal. So this signal particularly, we are just setting the signal for this particular word or process. So you can do the man and see what it will give you. Give you the usage also. Think. If you have our buildings, we have our start dump. Then let's go ahead to define our loop. Okay. Then we'll also define our read line. Because inside the loop we'll do our read line. So all right. I have another meeting by 12, guys. So I think I'll be leaving us. But we'll fix the time. If tomorrow is still fine by you, I'll still avail myself. Even during the day, I think I'll have some free time to go through this because it's a lot. There are a lot of things that you'll be doing, not just one. Because by just saying it, by just going through that thing, and me just going through the shield, you can see a lot of things that we're touching. You're going to be handling those things, so you need to break them down. So, but with these first steps, let's just do the loop for now and see how it fits into this. Okay. So, get built-ins. Let's define get built-ins. The ones that will get our values so that just happened. So here, what did I do here? What did I do? Let's keep this guy. Can you still see my screen?
Yes. Yes.
All right. So let's define the function to get built in functions. So let's see. Let's go to main.h. We have one there. So this one we just defined it here, but we didn't actually define a function that can do that. So let's do this. Yeah, let's see. Yes, enter. So I'll say int it's city string. Int get built in this guy will just take a character, a command. So get building, we're just going to pass a string to it. So based on that string, it's going to check through our commands and return the one that is available. So get built in is going to return what we call. So, but at the end, it's going to return function for us. So if it's going to return a function, this should not be its blueprint. Its blueprint should be this. You remember the last time that we tried to return a function, so we're going to still use this. So this is going to return this particular function. And this function should end here, open that one here. And the function data type is going to be data underscore shield. You remember? So our buildings are going to be like this. If that's the case of this, please, can you still see my screen?
Yes.
Okay. So, in this regard, we're going to define this guy. So, I forgot to end my definition. So, I'll say I. Let me end the definition here. I'll say this. And if and main is not it, but it's just going to do anything, but it's just my normal convention of just marking the end of main definition. So I think should do exit this guy. Let's define a file called get build .c. So the first thing we'll do, let's include our main file. Main.h. Once we include main.h, you already have the prototype, right? So we just defined it now. We'll say int. I'm going to return a function. It's built in. What this built-in is going to do, we say it's going to receive a string. The command string, based on that string, we're going to determine what's the command that it's returning, and it's going to return this function that has data shield as its parameter. So we don't really need to put it is still the same thing. Data, maybe getting wrong. You can do it this way, but you can still remove it, and that's good. That's very good to still work. So, let's see, buildings. This is the structure that we defined, right?
Power off.
The built-in.t, that's what we call it. So let's give a built-in. Built-in's an array definition of it. So what to save arrays, going to be plain T of them. It depends on the one that we created. I think we didn't define any one yet, but let's just put the definition. Let's just call this one null. Null for the name, null for the function, null. I'm doing it this way. The first one that we'll do. Let's start with CD. Let's do exit. Since that place we did echo and this. Sorry, give me a minute. Let's say, let's do this. So we're going to define exit also. So we'll say exit is exit underscore shield. So we're going to be defining that function also. So there are many other ones that we'll be defining, like CD into directory, but let's leave exit for now. We'll look at exit and we'll do the other ones. So let me define up here. I need an integer for iteration. Let's see, int I. Up here, I like defining them up there. I can define it down, but I like putting them up. So let's say for I let me initialize it here, put 0. The built-in at the top. I dot name. So each of those built-in, they have name and they have the function. So I'm checking the name. If the name actually exists, if there is name, if you didn't reach this node, this last one, so I want him to keep checking. So once he finds the one that is exactly what we are looking for, here we go. Going to say if underscore star copy. We're going to define this one also. Please remind me. This thing here is just coming my head now. So I need to define it also. Copy. So that one we did duplicate. So it's going to duplicate it. This one we want to copy. So we are defining our own. Don't want to be using the standard one. We can use the standard one. Or should we just use the standard one? Let's define our own to show that we really understand what we're doing. So not just use us. If our program is shifted to a system that doesn't have this standard built in, we don't want that to happen, or our system not to work. Let's define our own that will carry it along. So once this does the comparison, this built-in name is equals to the command that we are checking, you should stop. So we have the index of the one. If it comes in here and checks if this built-in name exists, so there is name, this value is going to be truthy. So it's going to return true. So that means there is name, it's not null. So if it is not and this I is at 0, it will enter here, then compare the built-in at I. So it will compare built-in at I dot name, sorry, it's supposed to be name because this command is string, so it's going to compare string and string. So name here, these two are the same, these two strings are the same, these names are the same, it's going to return 0. Our comparison is going to return 0. So if it's anything other than that, that means we didn't find it. So if it is that, we want to break this for loop. So we know exactly the index of where our command is. So we come down here and say, okay, now return I want you to return the built-in and the array that we define up there. So the array, the built-in array that we define there. Array at index I. So, dot f, that's the function we're going to be defining. So, maybe. So this is it. This will do. So this is where you keep adding your functionalities. You keep coming here to add them, just the way we did the last one for me. This is the way I like to structure it. So keep adding them here. Once you have them, you add them here. So this one will do the return automatically for you. So what you just do, you keep defining your functions out there, like the exit shield now. You define it, star comparison, you define it also. So let's exit this guy. And I think you have defined these things. You can go and pick them from your previous project. You don't have to start defining them from scratch if you so want to do that. So I think I will stop for now here. I have another meeting that I'm attending by 12. So David will let me know when you guys will have me tomorrow. You can have me during the daytime. I will be free. And also this evening also. Sorry, I had to go. I really wish I could continue doing this with you guys. It's always fun doing this.
Wow. Thank you very much, sir.
Yes.
Thank you very, very much.
I'll stop sharing my screen, but okay. So I hope that you guys have a glimpse of what we're doing and you're following. So if you will have me tomorrow, I would really appreciate so that we'll continue. But I'm just so sorry that I have to go now. Okay.
All right.
Thank you.
Thank you so much. We appreciate. David is not here now, so
Okay.
he told me earlier that he's having network challenges. He may not be with
Uh-oh.
us till the end. So
Okay.
maybe later he'll reach out to you. So I'll inform him what you said. Thank you so much.
All right. But I hope I'm able to give you some guides.
Yes. Just pick one or two things from here. Thank you.
Yes. So is there any question that I need to answer before I go that you're having?
There is a
Someone
hand.
raised.
One hand is up. I don't know if it's still awake.
Yeah, this guy. His hands has been up since for over 30 minutes now. I don't think he's still online. I don't think he's still here. But the hands has been up for a while now. I've been
All right.
monitoring. Yes, and also thank you very much, Mr. Elisha, for the breakdown.
All right.
Even though everything has not entered, but we have it recorded. So we'll be going back again to look at it. But I love the way you simplified everything. Thanks so much, sir. I really appreciate your time and effort.
All right. If you have me tomorrow, we'll continue. I think if we start doing those copy that I'm introducing you to it, I did it deliberately to introduce those things so that you see the way we are going about it. So those like copy, like duplicate, all those functions, I'm trying to define them myself. So if you implement those things, you can see how the structure will go in for you. Each particular, like exit now, we have his command separately. That okay, if someone enter exit, he checks, he finds exit, he's going to what? Call that particular function and execute exit. So we're going to implement the exit next time we come in with you guys. Or if you have opportunity to do it yourself, you carry on, no problem. But if you have me tomorrow, even during the daytime or in the evening like that, I will meet him. I'll really appreciate. But it's just that I had to go now. And I wish I could stay for us to finish to get to a particular level that I can say, okay, you will have full grasp. Okay? I'm so sorry that I'm leaving now.
Okay, sir. Okay, sir. We don't have a problem with joining us tomorrow. We don't have a problem with that.
All
If
right.
you're disposed, you can just tell Mr. David and he's going to put it up in the group and we all will join. We don't have a problem with that at all. We should be the one begging you to join us tomorrow, not the other way around. So we really appreciate if you come up tomorrow. Just tell Mr. David, and he's going to inform us in the group. And I believe many of us will join you also here.
All right. All right.
Thank you so
Thank
much.
you. Good night.
Okay, now it's time for us to go. Thank you all for coming around. Mr. Justice, also thank you too.
Yeah.
Good night, everybody.
Okay.
Good
So
night, everyone.
you can all say goodbye. See you tomorrow.
Thank you very much for the time. Thank you all.
Yeah. Bye bye.